Welcome to This Explainer. Today, we're breaking down network security literally from the ground up. And as we go through this, we're going to ground all this technical evolution in a really classic, time-tested analogy. I want you to think of your organization's network as a medieval castle. The firewall? Well, that's your moat and the heavily armed guards protecting it from the outside world. It is, without a doubt, the absolute foundation of digital security.
Okay, let's dive into this. It's kind of fascinating to look back at where our terminology actually comes from, right? Because long before it was used in real-life computing, the term firewall referred to a literal, physical metal sheet or wall. It was built to confine a fire inside a building or even within the engine compartment of a car. But what really shoved the term into our cultural and technological zeitgeist was its Hollywood debut in the 1983 computer hacking movie War Games. In the film, it's spoken by this bearded, bespectacled programmer character named Paul Richter, and that single pop culture moment basically inspired its eventual real-world networking namesake.
So back in those early days, as the global internet was really just beginning to take shape, network engineers desperately needed a way to segregate traffic. Enter the early 1980s routers. These acted as the direct predecessors to modern firewalls. Because they were already segregating networks, these routers effectively became the very first digital moats, separating that private, trusted internal network castle from the totally wild, untamed external internet.
Section 1. Form factor: the physical versus the virtual.
Now, before we look at how the guards actually operate, we have to know where they're stationed. When designing a network perimeter today, architects generally choose between two form factors. On one side, we have hardware firewalls. These are dedicated physical appliances. We're talking actual boxes sitting in a server rack. You can think of them as the physical gatehouse right at the edge of your network. Now, they do require a higher upfront investment, but they're incredibly effective for on-premise branch offices. Then, on the flip side, we have software firewalls. These deliver the exact same core security principles, but they run as software on virtual machines, standard servers, or cloud infrastructure. Think of these as the virtual guards dynamically patrolling your cloud workloads. They're highly flexible and usually operate on a license-based cost model. And honestly, here's the reality. Most modern businesses don't just pick one. They use a combination of both to protect their physical offices and their cloud environments at the exact same time.
Section 2. The evolution of the guards. The 4 generations of firewalls.
The history of the firewall is essentially this ongoing, decades-long arms race between brilliant network engineers and malicious hackers. It all started back in 1987 when engineers at Digital Equipment Corporation, or DEC, published the very first paper on packet filter systems. Just 2 years later, in 1989, researchers at AT&T Bell Labs developed circuit-level gateways to actually track connection states. Then, 1994, this was a massive leap. Network Translation Inc. released the PIX firewall, introducing network address translation to hide internal IP addresses. It was so successful that Cisco bought the company a year later. Fast forward to 2004, and Gartner officially defines the era of next-generation firewalls. So let's move forward and see how this builds, breaking down what each of these generations actually does.
Generation 1 is packet filtering. This is your most basic gate guard, just checking IDs at the door. It operates purely at the network layer, looking only at a packet source and destination IP addresses and its ports. It relies heavily on a deny-by-default rule set. If a packet isn't explicitly on the guest list, the firewall performs a silent discard. It just drops the packet without even bothering to tell the sender. But the problem here, this guard is stateless. It's like a guard who only checks the return address on an envelope but has absolutely no idea if the person delivering it was actually invited by someone inside the castle.
And that glaring vulnerability leads us directly to Generation 2, stateful inspection. This was a huge leap forward. Instead of just blindly checking IDs, the firewall became this attentive guard who actually remembers the context of a conversation. It tracks the specific state of connections, like the TCP handshake, right at the transport layer. This means the firewall actually remembers if someone inside your network initiated a conversation with the outside world, and it's only going to let external reply packets back in if they match that established expected state.
Now, what's really interesting about this slide is seeing this memory in action. Take a look at this real example of a state table from NIST. Notice the columns here. The firewall is meticulously logging the source address, the port, the destination, and this is the most important part, the connection state on the far right. It knows exactly which connections are merely initiated and which are fully established. So if an attacker tries to sneak a packet in by faking an established header, the firewall checks this table, sees there's no matching record, and just drops the threat immediately. No way it's getting through.
But of course, as attackers got smarter, they started hiding malicious code inside perfectly legal, established connections. Enter Generation 3, application or proxy firewalls. Think of this as your deep inspector middleman. This firewall stops direct connections between the outside world and your internal servers entirely. It operates higher up, at the application layer. The proxy acts as a secure intermediary. It literally intercepts the package, opens it up, inspects the actual content and payload for hidden threats, like say an unauthorized FTP put command, repacks it, and only then hands it over to the internal network.
And that brings us to today, Generation 4, the next generation firewall, also known as Unified Threat Management or UTM. This isn't just a single guard anymore, this is an ultimate security task force, because simply filtering by IP address and port, that's just no longer viable in a modern cloud environment. So NGFWs abandon relying solely on IPs. Instead, they combine deep packet inspection with intrusion prevention systems, antivirus, and TLS decryption. And most importantly, they control granular access based on user identity, integrating directly with things like Active Directory, and monitor the behavior of specific applications. It creates a highly intelligent, unified defense perimeter.
Section 3. Specialized Guards and Rules. WAFs and Silent Discards.
So, we have to ask, what happens when attackers stop trying to break through the front gate and instead they just exploit the public services a business actually wants people to visit? Well, that's exactly where a web application firewall, or WAF, comes in. While a normal network firewall is designed to protect the whole castle, a WAF is a highly specialized guard standing exclusively in front of the public-facing storefront of a business. Look, if you host a website or an app, you have to let traffic in. A WAF sits there analyzing that Layer 7 web traffic, specifically hunting for things like cross-site scripting, SQL injections, and DDoS floods. It protects the application's unique vulnerabilities, all without disrupting your legitimate customer traffic.
But despite all of these incredible advancements, from state tables to deep packet inspection to WAFs, we have to ask a pretty difficult question. Is the traditional network perimeter dead? Because there is a fatal flaw in our castle and moat analogy. If an attacker manages to steal a legitimate user's credentials or trick an employee with a phishing email, they cross them out. And historically, once an attacker gets past that perimeter firewall, they're suddenly a trusted entity. They have free reign to move laterally from room to room inside the castle completely unchecked.
Section 4. The plot twist. The Zero Trust Revolution.
So the crucial point is this. The core philosophy of modern networking has had a massive paradigm shift. It's simple but radical. We can no longer trust anyone simply because they happen to be inside the building. To solve this lateral movement problem, organizations are adopting the Zero Trust Architecture framework. As outlined by IRE journals, this involves multiple overlapping technologies working together. Identity and access management ensures only authorized users get in. Endpoint detection monitors the actual laptops and phones connected to the network. But the real magic here? Microsegmentation. Microsegmentation effectively takes the whole concept of the firewall and shrinks it down, putting a mini firewall around every single room, server, and application inside the castle. You don't just authenticate once at the front gate anymore. You have to prove who you are every single time you open a new door inside the building. It completely redefines perimeter security by making the perimeter, well, everywhere.
Which leaves us with a pretty fascinating reality to ponder. We've moved from physical walls stopping literal fires, to stateless routers, to highly intelligent deep packet inspectors, to a world where we trust absolutely no one. So I'll leave you with this to think about. If the perimeter is now everywhere and decentralization is the future, how is your organization's most sensitive data truly protected today? Take a look at your own network. You might actually be surprised to see just how many guards are quietly standing watch in the digital shadows. Thank you so much for joining me for this explainer, and keep learning.